Okay, let me start from the first, because I have discussed it on, but it is muted. No one has said. So I have. Okay, so today we will discuss the assignment 5 for the course MA 49. So the first question is, partition is given 0, this partition 0, 0.6, 1.2, 1.5, 1.8, 1.9.2. For this partition in the interval 0, 2, you have to find the norm of the partition. Okay. So partition I have write it down and I numbering it x0, x1, x2, dot 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 x6. Okay. So how the norm of a partition is defined? It is the supremum of xi minus xi minus 1. Okay, this is supremum of the sub interval is called the partition I equals to 1 to 6. Okay. So now calculate the difference between xi and xi minus 1. So if you calculate x1 minus x0, it will be 0.6, x2 minus x1, it will be 0.6, x3 minus x2, it will be 0.3, x4 minus x3, it will be 0.3, x5 minus x4, it will be 0.15, and x6 minus x5, it will be 0.05. So now find which one will be the maximum. So you can easily see 0.6 is the maximum. So the norm of the partition will be 0.6, right? Is it fine? Okay. So this is the first question we have done. So let's now move to the next question. You have to find the sum of the squares of the first n natural number. So we will prove it by so first you can easily check that first three condition will not hold, means if you simply put n equals to 1, you can check that means n equals to 3, the first option will not be correct. Sum of first square of the first three natural number will be 14, but this will give different answer. And for these two, again for n equals to 1, this side will be 0, but this sum will be 1, so option 2 will also not be true. And for n equals to 1, this will be 3 by 2, but sum cannot be fraction, so option 3 is also not correct. So option 4 will be correct. So we will claim that sum of this 1 to n k square will be n into n plus 1, 2n plus 1 by 6. Okay. Okay, can you mute please? Can you mute Santosh Yadav? Hello, can you mute yourself? Santosh Yadav? Okay. So we'll prove this by induction. So just check for p equals to 1. So this is the LHS is, if you put k equals to n equals to 1, it will be 1 square is 1. Hello Santosh, can you mute yourself? Hello? Okay. And now if you see the right hand side, it will be 1 into 2 into 3 by 6. So it is again 1. So p of 1 is true. Now for induction, assume, suppose that for n the statement is true, means Pn is true. So now assuming for n, we will prove that p of n plus 1 is true. So just take the summation k equals to 1 to n plus 1 k square. So it is 1 square 2 square dot dot n square plus n plus 1 square. So by induction we know the sum of first square of the first n natural number. So just write it down. It will be n into n plus 1 into 2n plus 1 by 6 plus it will be n plus 1 whole square, right? So then what it is, now take the n plus 1 common, n plus 1 by 6. So remaining it will be 2n square plus n plus 6n plus 1 plus 6. Now factorize this, means just write it down, then it will be n plus 1 by 6 into 2n square plus 7n plus 6. So if you factorize this, it will be n plus 1 by 6 into 2n plus 3 into n plus 2. So what you will get? Overall you get n plus 1 into n plus 2 into 2n plus 3 by 6. So now if you check the statement, here if you put n equals to n plus 1, you will get n plus 1, n plus 2 into 2n plus 3 by 6. So we have, assuming for n, we have proved that Pn plus 1 is true. So by induction we are done, right? So we have claimed that this is true. So option number 4 is correct. N into, so sum of squares of the first n natural number is n into n plus 1 into 2n plus 1 by 6. Okay. Now move to the question number 3. What you have to find the partition is given and the function 1 plus x square is given. So you have to find the UPF minus LPF. Okay. So just this is the function. If you draw it 0 to 1, it will be 1 like this. At 0 it is 1, at 1 it is 2. So it is the increasing function. So this is the partition is given 0, 0 0.2, 0 0.4. We are renaming it by x0, x1, x2, dot, dot, x5. How the UPFP is defined? It is the summation I equals to 0 to 5 because x5 up to 0, x0 to x5 it's there. And mi into xi minus 1. Where mi is the maximum of the function in the interval xi minus 1 to xi, right? And what is the LFP? It is the only change by mi by small mi, means it is the minimum of fx in this subinterval. So these two are UFP and this is LFP. Now calculate UFP. What it will be? The function, so maximum value of the function times the subinterval, length of the subinterval. So in this 0 to 0.2, length of the subinterval is 0.2. So we have written it. And what is the function of value? It is 1 plus x square. So what will be the maximum in 0 to 0.2? So as this is increasing, maximum value will be attained in the right hand side of the subinterval, means at the point 0.2. So it will be, so mi it will be 1 plus 0.2, and for the next interval 0.2 to 0.4, function value it will be 1 plus 0.4 whole square. In the length of the subinterval again it will be 0.2. So now so on, just write it down, 1 plus 0.6 whole square into 0.2 plus 1 plus 0.8 whole square into 0.2, and in the at last it will be 2 into 0.2. Okay. Similarly calculate the LFP. Here again the maximum we will write it minimum, and for 0 to 0.2 minimum is 0, so 1 plus 0 whole square, 0 square into length of the subinterval is 0.2. And for the next one it will be 1 plus 0.2 whole square into 0.2, and so on, 1 plus 0.4 whole square into 0.2 plus 1 plus 0.6 whole square into 0.2 plus 1 plus 0.8 whole square into 0.2. Okay. So now just subtract UFP minus LFP. You can see that it will be 0.2 into 0.2 whole square plus 0.2 into 0.4 whole square minus 0.2 whole square plus 0.2 into 0.6 whole square minus 0.4 whole square plus 0.2 into 0.8 whole square minus 0.6 whole square plus 0.2 into 1 minus 0.8 whole square. Now you can see that 0.2 and this 0.2 here is sign is alternative, so these two cancel out. Similarly 0.4 whole square into 0.2 into 0.2 minus 0.4 whole square cancel out, so only remain 0.2. So this is 1.1 by 5, right? So you get UFP minus LFP is 1 by 5. So which option is correct? Option number 1 is correct. Okay. All the options are others false. So this is the question number 3. Now move to the question number 4. So what it is saying, P with the partition, all partition in AB, and AP is a function from AB to R, and P1 is a particular partition. Then you have to show that UFP1 is an upper bound of the set LFP, because upper bound is not unique, so the will not be, it will be an of this set LFP for all P's. So we will show that this is true. So let's come to the answer. So how to do this? You know from earlier result, or it's done in the class, that for any partition P1 and P2, this inequality always hold. LFP1 is less than UFP2, right? For any partition P1 and P2. Okay. So here take any partition this P, and P1 is given. So for that we will apply this. So for any given partition P and P1, we have LFP less than UFP1. P1 belongs to script P, P belongs to script P. Okay. So now this inequality holds for all p in P. So now take the supremum over all p in the left hand side, and as P1 is a fixed partition, so it will remain same. So what you will get, supremum over all f p is less than equals to u of P1. Okay. So what is the meaning of this? Means supremum of this set is always less than equals to this number, right? Means u of P1 is an upper bound of this set, right? Because supremum is less than this. So we have shown that u of P1 is an upper bound of this set LFP. This we have to prove, right? So this one, so it is true. So question number 4 is done. Now come to the question number 5. What it is saying? Function is given 1 by x square. You have to check whether it is Riemann integrable in the interval -1 to 1 or not. So because note that this function is not defined at the point 0, so that's why we have defined, because at 0 it will be undefined, infinity. So we have defined it at 0 point at the 0. Now you have to check, you can define any value, we have just defined it to here, you can define also the other values. Now you have to check whether it's Riemann integral or not. But note that one condition for necessary condition for Riemann integral, that function should be bounded, right? Otherwise you cannot define the UFP upper sum. So function should be always, we will always assume for Riemann integral that function is bounded. You can check that this function fx equals to 1 by x square in -1 to 1, it will look like this. So f is unbounded in the neighborhood of 0. Means at 0 you can define whatever value, but as it is at infinite discontinuity, it will never be continuous and it will be always unbounded. So this function is not Riemann integral, right? In the interval -1, 1, because in the neighborhood of 0 the function is unbounded. So the option is, so the second option false. So this is not Riemann integral, right? It is not true. Okay. Now let's move to the question number 6. So we have discussed up to 5, but because no one said my mic was muted, so I have repeated the question 1 to 5 again. Now let's do up from the question number 6. So what it is saying, that f is a Riemann integral function and f a equals to fb equals to 1 is given. So you have to find integral a to b f dash t dt. So note that here f dash they have written, means f have differentiable they have assumed, and also they have written integral a to b f dash t dt, means they have also assumed that f dash is Riemann integral. But note here, in general, note f is Riemann integral does not imply f dash is Riemann integral. You can find some example. I will give this as an exercise, means you can check, or you can find some counter example where f is Riemann integral and it is differentiable, but f dash is not Riemann integral. Okay. So as here they have defined integral a to b f dash, means they have assumed that f dash is Riemann integral. Now you have to find this integral a to b f dash t dt. Okay. So there is a one theorem, you know, that this is the theorem, it's done in the class. If f is integrable, suppose I denote it by some h, then it will be easier for you. Okay. If h is integrable and h is the antiderivative, means h equals to g dash for some g, then integral a to b hx dx, it will be g of b minus g of a, right? So this was done in the class, so we will use this theorem to prove this one, right? So this is the theorem is done in the class. So now f is a function, it's given. Now we have to find integral a to b f dash t dt, right? So what you will take? So for h we have h equals to f dash, right? Means you can take h equals to f dash. Then what will be g? G will be f, right? So take h equals to f dash and g equals to f, right? Then what, by this theorem what you will get? It will be fb minus fa, right? Okay, and fa and fe are given, right? Both are 1. So what it will be? So it will be 1 minus 1. So it's 0, right? So what we will get? Integral a to b f dash t dt is 0, right? So option number 4 is correct. Okay, is this fine? Okay. Now let's move to the question number 7. So you have to say that integration 0 to 1 dx by 1 minus x to the power alpha, this does not exist finitely. Okay. So you have to, so that for which alpha this will does not exist, this integral. Okay. So we will find the range of alpha where it will not exist. So if you do the integration, what you will get? So what will be the integration of this? So means you can write 0 to 1 minus x to the power minus alpha dx, right? So if you integrate it out, you will get minus 1 minus x to the power minus alpha plus 1 by minus alpha plus 1, and from 0 to 1, right? Now here no two case will arise, right? Oh, we will have, so if alpha equals to 1, then it is not defined, right? So alpha cannot be 1. Then the denominator will be undefined. So alpha cannot be 1. So what happens if alpha less than 1? If alpha less than 1, what you will get? Then minus alpha plus 1, it's positive, right? If alpha is less than 1. So this is fine, right? If you put 1, then it will be 0, and for 0 it's fine. So if alpha is less than 1, there is no problem. You will get, what you will get for minus, it will be 0 minus, if you put x equals to 0, it will get 1 by 1 minus alpha, right? So this we will get if alpha is less than 1. And what happens if alpha is greater than equals to 1? For alpha equals to 1, this denominator will be undefined, right? And if alpha is strictly greater than 1, then minus alpha plus 1, it is also negative, right? So this is greater than, it will be negative if alpha is greater than 1. Means this will be 1 by 1 minus x, and if you put x equals to 1, this will be blow up, right? It will goes to infinity. So if you put here, then it will be infinity, right? It will goes to infinity. So for alpha greater than equals to 1, this is not well defined. Okay. So here it will only give the finite value for alpha less than 1. Now the question is said that for which value the integral is not exist finitely, right? So for alpha greater than 1, this does not exist finitely. Okay, so option number 4 is correct. Mean here where it's saying that because where it is not finite, right? So for alpha greater than equals to 1, integral 0 to 1 dx by 1 minus x to the power alpha, it's infinite. Okay, so the option number 4 is correct. Okay. Okay. Okay, now move to the question number 8. What it is saying? Two sets are given and a plus b is defined. For a plus b, how it is defined? It is a plus b, where a belongs to a and b belongs to b. Now you have to find the which options will be correct. Supremo a plus b, supremo a minus supremo b, and the other on the. So note that just take by taking some example, you can always eliminate some examples, some options. So just take a equals to 0, 1 and b equals to 2, 3. Then what will be the a plus b? This set means you have to add these two, right? So what will be this set? Means if you add 0 with 2, you will get 2, right? 0 with all in between and 3, you will get 3. So if you add 0 at most, you will get 2 and maximum. This is the least number you will get. And 1 with add, when you will get 1 plus 3, you will get 4. So you will basically get this interval if you add a plus b, and in between means everything will be there. So plus b will be 2, 4, where a and b are given by this. So what will be the supremum of a? It's 1, right? And supremum of b, it's 3, and supremum of a plus b, it's 4, right? So what is the first option? Supremum of a plus b is supremum of a minus b. It's false, right? Supremum of, if you calculate a minus supremum of b, it's minus 2. So the first option is incorrect. What is the next option? It's saying that supremum of a plus b is maximum of supremum and supremum b. What is the maximum of supremum a and supremum b? It is 3, right? But supremum of a plus b is 4. So the second option is also incorrect. Okay, now in terms of infimum, so what will be the infimum of a? Infimum of a is 0, right? Infimum of a. Infimum of b is what? It is 2, because the interval b is 2, 3, and infimum of a plus b is, a plus b is 2, 4, so infimum is this 2. Now what is the minimum of infimum of a, b? Infimum of a, infimum of b, because minimum 0, 2 is 0, 0 and 2, so it is the minimum is 0, but infimum of a plus b is 2. So again the option 3 is not correct. So the only option 4 is correct, right? Infimum of a plus b equals to infimum of a plus infimum of b. So we'll prove this one. Means we have eliminated by counter example first 3. So for the last one we have to prove it, right? So we'll prove. We will show infimum of a plus b equals to infimum of a plus infimum of b. Okay. So how to do this? So first note that this side. Note that infimum of a plus infimum of b is less than a plus b for all a belongs to a and b belongs to b, right? Because infimum is the lowest number, so infimum is less than a, as infimum of a is less than a and infimum of b is less than b. So using this is correct, right? Now what will, now a plus b is in ab. So now take the infimum. Now this left hand side is a fixed number, right? Because infimum a, infimum b, and right hand side a plus b in the set a plus b. Now take the infimum over all a plus b belongs to a plus b. Then what you will get? You will get infimum of a plus infimum of b is less than infimum of a plus b, right? A plus b. So this is the one side. We have proved infimum of a plus infimum of b less than equals to infimum of a plus b. So one sided we have proved this side is less than, right? One side. Now we have to prove the other side, means infimum of a plus b is less than infimum of a plus infimum of b. So now the other side. Okay. Now not this. So now this side. First of all we have proved this side as infimum of this set a plus b, it's always less than a plus b, right? As a plus b belongs to a plus b, means infimum is the always the smallest, so this is true. Okay, now what you will do? Now fix a and take infimum over all b belongs to b. So what you will get? Then infimum of a plus b is less than a plus infimum of b, right? So you will get this. Now what you will do? Now take infimum over all a belongs to a. Okay, now what you will get? Infimum of a plus b is less than infimum of a plus infimum of b. Okay, so we have proved the other inequality also. So by 1 and 2 we are done. We have this equality, right? Infimum of a plus b equals to infimum of a plus infimum of b. So we have proved the last option. This is correct. Option 4 is correct. You can also easily check by this also that for supremum also, supremum of a plus b is supremum of a plus supremum of b. So this is also true for supremum. Okay. So this you can check. Okay. So it is done. Now move to the question number 9. So what it is saying, you have to find the average value of fx equals to sin x in the interval 0, pi. I have said in the last tutorial that for a function f, what is the average value? Average value, how it is defined? Average value of fx is defined, take the length of the interval, it's pi, 0 to pi, so divide by the length of the interval and take the integration from 0 to pi fx dx, right? So this is called the average of fx on 0 to pi, this interval, right? So here fx is sin x. So just put here, so average value of sin x on 0 to pi, it will be 1 by pi integration 0 to pi sin x dx, right? Now do this integral. What is the integration of sin x? It is minus cos x, right? Minus cos x from 0 to pi. If you put this value at the point pi, cos pi is minus 1, so it's 1, and at 0 it's again minus 1, right? Cos 0, what is the value? So minus of minus 1, right? This means it's 2 by pi, right? So average value of sin x in 0 to pi, it's 2 by pi. So which option is correct? Option number 2 is correct, right? Okay. Now move to the last question. What it is saying? You have to find the value of the integral 0, 0 to pi by 3 sec square x dx, right? Now you can use this fundamental theorem to calculate this, or easily just means what you will do. So you can take fx to be sec square x dx this. So what will be the antiderivative of this? So just take this, take gx to be tan x, right? Then f is g dash x, right? Because derivative of tan x is sec square x. So then what will be this integral? Integral 0 to pi by 3 sec square x dx means this is integral 0 to pi by 3, it's fx dx, right? So now by the fundamental theorem of calculus, what it will be? It will be g of pi by 3 minus g of 0, right? By the fundamental theorem. Of calculus. Right. So what is the value? G is, this is tan pi by 3 minus tan 0, right? So what is tan pi by 3? It's root 3, right? Not is tan 0, it's 0, means overall answer is root 3, right? So which option is correct? Option number 3 is correct. Okay, so all the options are incorrect. So you have completed the assignment 5. So this is all the questions. Okay, so we'll upload it. Any question from this? Is it fine? Yes?
No, sir.
Okay. Okay, so I'll upload this. Okay, then bye. Let's stop for today.
Sir.
Okay, bye.